In this video, we're going to continue to look at the difference quotient for a variety of function equations. Let's take a look at this quadratic function equation. Now, I've already written out the definition of the difference quotient. So I want to start with g of x plus h. So every time I see an x, I'm going to replace it with x plus h. Okay. So simplify, that's going to be x squared plus 2hx plus h squared minus 2x minus 2h, distributing the negative 2 here. No like terms to combine, so there's g of x plus h. So go back to the definition. We now know what g of x plus h is. Now remember the original function, that's g of x. In this case, that's x squared minus 2x all over h. Distribute the negative, which I'll do here and here for this. Okay. All right, so subtract out the terms. Now, what do you notice? Every single term has a factor of h I can divide out. And this would be my difference quotient. Okay, let's take a look at one other quadratic then. So this one's a little bit more involved, but again, I've already written out the definition of the difference quotient, and I'm going to do g of x plus h now. So again, every time I see an x, I'm going to replace it with x plus h. So again, I'm going to do the x plus h squared first. And distribute the 5. Now, don't forget, I need to distribute the negative 3 now. Again, no like terms here. So there's my g of x plus h. Now, let's go back to the definition. We now know what g of x plus h is. Again, go back to the original trinomial function here. Okay, so I'll distribute the negative again. All right, so simplify, subtract out, and these subtract out, and those subtract out. Again, every single one of these terms has a factor of h I can divide out. Okay. So there is my difference quotient. All right, so let's take a look at some other functions that are not quadratic. Now, I've changed it so it matches your sheet. F of x is equal to the square root of x. Again, I've already written out the definition of the difference quotient. So now f of x plus h. Well, this is pretty simple. That's just going to be square root of x plus h. Every time I see the x, I'm going to replace it with x plus h. Okay, go ahead and put it into the definition now. Now, In Math 051, if you had two radicals in the denominator like they are in the numerator here, we would say to rationalize the denominator. Well, I could do something similar, but it's what is called rationalizing the numerator. And if you recall, when you rationalize, the terms stay the same. The only thing that changes is the sign that is in between. So in this particular case, it's still the square root of x plus h, and it's still the square root of x here, but it is plus in between, but I have to do it for the bottom also, because I'm multiplying by 1, and when I multiply by 1, nothing changes. Now, why is this nice? Because now I'm taking the product of a sum and a difference. You already know the square root of x plus h times itself is just x plus h. This term and this minus this times this, but that's 0. So the only thing I have left then is the square root of x times the square root of x, which is x. So it'll be minus x. Okay. Now, I'm going to leave the denominator the same. I'm going to do h, and then in parentheses, I'm going to put this. Okay, let's simplify the numerator. So that's just h on the top. Rewrite the bottom. Now, notice, I can now divide out a common factor of h from the top and on the bottom. So here I have this. So this is my difference quotient. Let's write it over here. All right, so the only other one I would like to be able to take a look at is a rational or reciprocal function. Okay. All right, so again, this one I've done ahead of time, and I'll go through the steps with you. Again, already written out the definition of the quotient rule, and you can see right here, I did j of x plus h, that's just 3 divided by x plus h. Now, you can see from this, it's just j of x plus h minus j of x all over h. Now, I want to simplify these two fractions down into one, so I need a least common denominator. Well, the least common denominator is these two denominators multiplied together. So it's x times quantity x plus h. So I've rewritten each denominator with its LCD, which again is x times quantity x plus h. And what factor am I missing here that is in my LCD here? I multiply top and the bottom fraction here by x. Here, what factor is missing here that's in my LCD? That's x plus h. So I multiply the top and the bottom by x plus h. Okay. Now, from this step to this step, I distributed this -3, okay, here and here to get this and this. So -3 times x is -3x, and -3 times h is -3h. Bring the 3x down, and I can combine them into one fraction because the denominators are the same. 3x minus 3x, that's 0, so they subtract out. I'm left with -3h divided by x plus h all over h. Now, if you recall, look up here. If I have 1/2 divided by 5, you know I can rewrite this as 1/2 divided by 5. But how do you divide fractions? You multiply by the reciprocal, and 1/2 times 1/5 is 1/10. Now, notice this 5. Where does it end up going? It ends up being in the denominator of the one fraction. So now let's come back here. I have this divided by h. So I'm going to rewrite it so that the h here goes in the denominator of the one fraction. Once that is the case, then I now can divide out a common factor of h for both, and I'm left with -3 divided by x times a quantity x plus h. So the difference quotient for this, in this case, is -3 divided by x times quantity x plus h.